Whenever you type a query into a search engine or enter your password on a login screen, you are interacting with text data. Manipulating that text is one of the most common tasks in all of programming. In Python, we handle this text using strings. A string is a valid sequence of characters that the programming language recognizes as data rather than executable code. This section shows how to write them. To create a string literal, enclose text in single, double, or triple quotes for multiple lines. Interestingly, an empty set of quotes is still perfectly legal and recognized by Python as a valid string object. Strings give us a standardized container. They take the unpredictable variations of human language and package them in a way that machine logic can process safely. Once we have text inside a string, we need a way to target specific parts of it. Strings are divided into distinct, ordered slots that programmers access using square brackets. This is a technique called indexing. Notice how the counting starts. The first physical character of the word doesn't sit at position 1, it sits at slot 0. If you have a massive block of text and don't know the exact length, counting from 0 isn't helpful. Python solves this with negative indexing. You can count backward from the end, where -1 maps directly to the last character. You can also pull out chunks of text using a colon to slice the string from a start position to an end position. The start index is included, but the slice stops exactly one position before the final index. We can process these chunks further by concatenating them, using the plus operator to snap different slices together into new words. We can also use a for loop to traverse the string, stepping over each individual character one by one to inspect it. Mastering indexing shifts how you interact with text. You stop seeing a single block of ink and start seeing a precise, manipulatable coordinate space. Python provides built-in tools called methods to manipulate these coordinates automatically. But there is a strict rule here. Strings are immutable. A method cannot permanently alter the original string in memory. Instead, it processes the text and spits out a brand new string. These methods fall into clear categories. You can measure a string's length with the len function, or force case conversions using methods like upper, lower, and title to fix messy data. Boolean checkers like isAllNum, isDigit, and endsWith scan the text and report back true or false. Then there are formatting tools that adjust layout, like stripping whitespace with lstrip, or padding a string using center and zfill. Predict the output for these two test paper commands. The first command centers wonders within a 12-character space, filling the rest with asterisks. The second returns false because the string contains letters, meaning it's not exclusively digits. These methods are your industrial filters. They take chaotic text typed by users and clean it into standardized data that algorithms can safely process. Let's apply these concepts to a practical challenge. Here is a program from the text designed to check if a string is a palindrome, a word that reads exactly the same forwards and backwards. The algorithm initializes an empty string variable. It loops through the original string, adding each character to the front of the new variable, building it backwards. Finally, an if statement compares the rebuilt string to the original input. If they match, we confirm the palindrome. To manipulate text effectively, keep this toolkit in mind. The zero-based indexed for precise location extraction, paired with built-in methods to format, check, and modify the data safely. By combining a precise coordinate system with these functional methods, you move past simply reading text on a screen. You are structurally engineering it.